Hello everyone, Paul the geologist here to show you how to identify rocks. So I'm going to assume that you've already done the minerals and I'm going to assume you've taken the syllabus quiz so you can actually see this. So as with rocks, rather as with the minerals, we have a rock quote unquote quiz that is actually a lab and we have a spreadsheet to identify them. So as with the minerals, you want to go ahead and download that spreadsheet or at least open it. Don't try to look at it on my courses. It will not work. So hopefully you recall from your reading, because hopefully you've done the reading, that there are three different kinds of rock. Igneous rocks that form from molten rock, sedimentary rocks that form either from sediment or from chemicals precipitating out of usually seawater, but sometimes fresh water, and then metamorphic rocks that form by applying heat and pressure to other rocks. And you can see that we have a tab for each of the three different kinds of rocks. So how you identify a rock kind of depends on what kind of rock it is. So if we look at the quote unquote quiz that you have to do, um, and as with the minerals, we're going to be looking at it from my point of view, not yours. But we can see that first of all, I tell you if the rock is igneous, sedimentary, or metamorphic. So you'll know right away over here what tab to be in. Obviously, in the real world, geologists need to be able to tell those apart. But for our purposes, I let you know which one, what it is. So, how you use the graph, or rather the grid, kind of depends on what kind of rock you're identifying. Okay, so let's take a look at igneous first. So, so if we look at igneous rock, I give you a description and a picture. The picture is nice. Pictures are pretty. Ignore the picture for identification purposes. Okay. We don't identify rocks based on pictures, just like we don't identify minerals based on pictures. Okay. So I tell you it's igneous, and then I tell you it's dark in color. Right. I can't see any mineral crystals, and I don't see any air bubbles either. Okay, so let's go back and look at our igneous rock grid. Now, there's directions down here. If you prefer words, that's awesome. There they are. But I'm going to show you how to do this. And so, hopefully, remember from your reading that we identify igneous rocks based on two different things. Okay, texture and composition. Right, texture refers to how big the mineral crystals are. So if you look at a rock and you can see interlocking mineral crystals, now I don't mean you can squint and see something that looks a little bit like a crystal. I mean the rock is made of interlocking mineral grains. Think about your granite countertop. Okay, that is coarse grained. If, however, you look at the rock and you can't really see mineral crystals, it's kind of, mush o igneous rock, as I like to say. We call that fine grain. If you look at it and it looks like glass, that's obsidian, okay, and a glassy texture. And then if you look at it and it's got bubbles in it, that we call that a vesicular texture. Okay, so that's texture. And then composition refers to how much silica, SiO2, is in the rock. Now, we do not identify minerals based on color. That was never one of the properties we talked about because color can be kind of misleading. In igneous rocks, however, color, or at least dark versus light, can be helpful. Mafic igneous rocks here that don't have a whole lot of silica in them. Um, Tend to be darker in color. Felsic igneous rocks over here that tend to have a lot of silica in them tend to be lighter in color. Okay, and then intermediates are, well, intermediate. Okay, and so by knowing the texture and the composition of the igneous rock, you can kind of make those two things meet to get a name. Okay, and so if I look at the description of this particular rock, we can see it's dark in color. All right, dark in color. Awesome. Okay, so come back over here to the grid. Dark in color is somewhere, it's selecting the whole thing, is somewhere down through here, right? So it's either scoria, basalt, or gabbro. All right, so we got it narrowed down to three. Hooray. So what else? I can't really see any individual mineral crystals, and I don't see any air bubbles. Okay, so no bubbles rules out scoria. So now we just need fine grained or coarse grained, right? Remember that not seeing any mineral crystals is fine grained. Um, the rock is basalt. Awesome. fill in basalt. We're in the answer. Move along. Okay, so that's how we identify igneous rocks. So let me just show you, just take you through this really quick, right? So if it's smooth, glassy, breaking along a curve, that's obsidian, right? If it has visible air bubbles, that's either scoria or pumice, right? If it's mafic, it's scoria. If it's felsic, it's pumice, right? And then if it has two distinctly different crystal sizes, it's what we call a porphyry. I've got that kind of over here on the chart. Okay, so so pumice, scoria, porphyry are kind of the obvious, and then obsidian are kind of the obvious ones that you can kind of eliminate right away, right? Then use the grid, right? Use what I tell you. Mafic, if it's dark in color, it's mafic. If it's light in color, it's felsic. If I say it's somewhere in between, it's somewhere in between. Match up, the composition with the texture and give it a name. Okay. Fill the name in. Once again, it's a quiz. Your professor is going to have to grade it by hand. Give them a couple of days, and they'll get that grade in for you. Okay, so that's igneous. What about sedimentary? Okay, well, sedimentary, we have a couple different kinds. We have what we call clastic sedimentary and chemical sedimentary. So if I go over here to the sedimentary tab, we can see the clastics over here and the chemicals over here. Okay, clastic sedimentary rocks are made from sediment, right? From basically pieces of other rock, right? And we name them according to the size of the sediment that makes up the rock. Now, we have a fancy thing called the Wentworth grain size scale that we could use to actually classify these. Don't worry about that. You all have an idea about how big a pebble is. Sand is sand. You've all been to the beach. Silt is about baking flour size. And then clay is clay. It's very, very fine stuff, right? And so if the rock is made out of pebbles, it's either a conglomerate or a breccia, depending on if the pebbles are rounded or angular. If it's made out of sand, it is oddly enough sandstone. If it's made out of siltstone, and if it's made out of clay-sized particles, it's shale, right? So look for the grain size for classic sedimentary rocks to give it a name, right? And so lots of different grains, but they all seem to be sand size. If the grains are sand size, the rock is sandstone. Okay, simple enough for that one. Let me see if I can find a chemical one. Here we go. So and let's see, there we go. So this rock is soft. Scratch it with my keys. It's light in color. Seems to have fossils in it. Okay, so let's go back here. I don't give you grain size, so it's not clastic. It's going to be chemical, right? And if you just kind of look at the descriptions of the rock, you'll be able to match the description I give you with the description in the grid, right? Light in color, soft, frequently has shales, limestone. And yes, indeed, that is a piece of limestone, right? And so, yeah, so there's the sedimentary rocks. So now let's think a little bit about metamorphic rocks. So these are rocks that are formed by applying heat and pressure to other rocks. I just made that column a little bit bigger so we can see the whole description. And so there's two kinds, foliated and non-foliated. Foliated have a kind of a layered texture to them for a number of reasons, but they do. And so, and the nice thing about foliation is the more pronounced the foliation, the higher grade of metamorphism you're looking at, or the more heat and pressure were applied to the rock. Now, not every metamorphic rock rather has foliation. Sometimes, there's a whole class of metamorphic rock, including, for example, the marble in your bathroom. That is non-foliated. It doesn't really have layering in it. Okay, so we have two different kinds of metamorphic rocks. So let's take a look at the questions. Let's come down here, and so I kind of in the description I tell you whether or not it's layered or not, right? And so this rock is layered. Okay, so it's metamorphic. So we're going to be on the metamorphic tab, obviously. Layered tells you it's foliated. And then big visible grains of the mineral mica, also some garnets and other minerals. So if we come back here to the to the grid, we can see, foliated. We know we're foliated. Big visible mica grains, right? Visible mica grains, right? So you'll match the description to the rock, and then give it a name, put the name in the quiz, you're good to go. Okay. We and the non-foliated are going to be the same way. Let me see. Let me see. Oh, there we go. There's a non-foliated one, right? And I tell you, it's not layered. That's kind of how you know it's non-foliated. We know it's metamorphic. I tell you it's not layered. That makes it non-foliated. Coarse-grained interlocking crystals. Well, if I come back here and I look here, and I see, let me see, and we can see over here non-foliated. It's not black and shiny, white and coarse-grained, and sure enough, it's marble, right? It's not sandy with interlocking mineral grains. I didn't say anything about, anything like that. And it's not flattened pebbles. So just, sort of eliminate things, get to marble. And yes, that's what marble looks like out in the wild. Okay, so there we are, identifying rocks. This is how we identify rocks in the real world too. Our grids are just much bigger. So anyway, okay, identify some rocks, and your instructor will get around to grading it as soon as they can, I promise. All right, y'all have a good day. Bye-bye.